All right, let's continue graphing linear equations. And we've talked about how to graph using a table, talked about direct variation and the intercepts. We'll talk about the important concept known as slope and rate of change. We'll talk about how to interpret and find the slope of an equation, and then how to use that eventually to help us graph. So first of all, let's just start off by talking about which of these triangles would you consider to be the steepest? So in determining that, I'm sure you'd look at, which one? Go ahead and choose one. Green one? Good. I chose that one too. Why would you choose that one? Well, because it goes up the most compared to how far it goes over. The yellow one isn't very steep because it rises a little bit as it runs. Purple is pretty even as far as how much it rises and how far it goes over. The blue, we might say, well, that one is the least steep because it goes downhill, maybe, right? If you're sitting in a wheelchair and you're sitting at the top here, you'd roll right down. So, we determine steepness based off of how high something goes in comparison to how far it goes over. This red one wouldn't be considered steep if it was the same height, if we just extended the ramp further down. So we keep that in mind. It wouldn't be as steep if we were to go that way. So steepness is a ratio. We'll talk about what that ratio is, and I'll give you a little song to help you remember how to find slope.
Difference of the y and the difference of the x, also known as rise over run. Divide the two, and then reduce, then you got slope. The difference of the y and the difference of the x, also known as rise over run. Divide the two, and then reduce, then you got slope. When I'm sitting in math and I'm trying to find how to get the slope of the line, I think about the rise and about the time, and I think the song, and I bet we find half slope, come on, one slope, come on, two slope, come on, that's two slopes. Think I'm a dope, I gotta say nope, I'm gonna find a slope. The difference of the y and the difference of the x, also known as rise over run. Divide the two, and then reduce, then you got slope. Okay.
All right, so hopefully you enjoyed that. So in finding the slope and the rate of change, let's put down in words and in picture and in symbols what this means. So slope of a non-vertical line is the ratio of the vertical change, known as the rise, to the horizontal change, known as the run. We can do that between any 2 points on a line. The slope of the line is represented by the letter M. So in words, slope equals the rise over the run. Okay, we can also think of it as the difference of the y and the difference of the x. So we can write that here. And that's how we can remember it in words. Okay. Symbols, we talk about m because that's what we refer to as slope. Slope is the m. y2 minus y1 and x2 minus x1. That just means basically difference of the y and difference of the x's. So we're subtracting the y values, subtracting the x values, the 2's and the 1's. That just stands for corresponding x and y coordinates. So this is one xy coordinate. This is another xy coordinate. The other way we represent it is this triangle delta, delta y and delta x. That just means change in y over change in x. And if we take a look on a graph, we said we can take any 2 points. We take a look at its rise in comparison to its run. So how far do I rise from one point to the next compared to how far I run? Okay, so if you remember slope in those 3 formats, you will do well. And maybe you just sing the song in your head all the time. So here's how we find slope on a graph. Difference of the y and the difference of the x. So the y values from this point to this point, we're going up 2, we're rising 2. I could have gone this way too. And then I run 6. We always go left to right, just like when you read. So the slope, m, would be 2 over 6, and we can simplify ratios. So 1/3. Okay. Now what do we do? So if I have 2 points here, notice if I'm finding the difference in the y between these 2 points, well, it goes up 1, but it doesn't run at all. So the run is 0. So a slope would be 1 over 0. And 1 over 0, we can't do in math. Can't divide by 0 very well. So we refer to that as an undefined slope. We say that it doesn't have a slope we don't have a definition for that because, first of all, is this line a function? No, it's not a function. There are multiple outputs for this input here at -2. So it's not a function, it doesn't have a slope. All right, so now let's find the slope of the lines to these points. So 5, 2, and 4, -1. Okay, so if I'm looking at the line that connects these points, if I want to find the slope of that, first of all, well, as I'm looking left to right, it's going up. And it looks fairly steep, but I can find the rise to the run. So I'm going up 1, 2, 3 units and going over 1 unit. So 3 over 1, and I could simplify that as a slope of 3. Okay, -2, 3. So if I can graph these points, all I got to do is just compare them, their rise to their run with the known points. So from this point over to this one, up, I'm going 3 units up, and from -2 over to 4, that gets me 6 units. So rise over run, 3 over 6, 3/6 is 1/2, or 0.5. Okay, so if you're comfortable with that, you can graph those and find the rise over run. Another way that you can find slope, we talked about using the symbols. Remember, if we refer back to that formula, think the difference of the y and the difference of the x, divide the two, and then reduce. Then you got slope. So if I want to look at it visually, I can find the rise over run. So this one's going, it's not rising, it's dropping, but we still refer to that as its rise. So I'm going from 4 down to a height of 1, so that's -3. And then we always look to go left to right, so from -3 all the way over to 4 is a distance of 7. So -3/7 would be the slope there. Now, if I wanted to find just using the coordinates, if I didn't have a graph, we have the formula sitting up here. M equals difference of the y's. So 4 and 1 are my y values. So I'll subtract those two, 4 minus 1. Now here's the important part, the y2 and the x2. So if I start with this point, this would be considered my y2, this would be my x2. So this would be my x1 and this would be my y1. The order doesn't matter, just as long as if I'm subtracting 4 minus 1, this would be my y2, this would have to be my x2, so I'd have to do -3 minus 4. 4 minus 1 is 3. -3 minus 4 is -7. Notice if I flip things around, and I'll do that for you to prove to you that it works. You don't have to take my word for it. If I subtract 1 minus 4 on top, take those as my y values. Since I start here and subtract that y, I need to start with this x, and 4 minus -3. 1 minus 4 is -3, and 4 minus -3 is +7. So notice no matter which method I use, I get a value of -3/7. Okay, so why don't you try number 4, see what you get. You can try either method or even try both. Okay, so if I plot those points, I see I go down 5 over 2. Or if I decide I want to subtract them, if I start with 3, subtract -2 as my difference of y's. Difference of the x's, 1 minus 3, simplifies as 5 over -2. The thing with slope, I could change this to -2.5, but typically we want to keep that as an improper fraction because it makes more sense later on as we start using slope to graph. So you can just keep it as an improper fraction. helps later on. Find the slope of these two lines, please. Pause the video and see what you get. Okay, so hopefully you noticed in the first set of points, the line through those two was a flat line, didn't rise any. So rise of 0, and it ran 6. And if I subtracted those points, they got the same thing. 0 divided by 6, or -6, gives me 0. And so this would be a slope of 0, or no slope. Okay, I may have said that wrong earlier. So 0 slope we could refer to as no slope. But in this example over here, it's a little bit different. 3, 5, and 3, 1, it has a rise, but it doesn't have a run. So we end up dividing by 0, which we can't do. So we'd say it has undefined. It's an undefined slope. We just can't put it in words what this is. Also because it's not a function. Okay, so 0 slope or no slope because it doesn't rise. This one is undefined. So the 4 major types of slopes, we'd say we'd have a negative slope. And that's where it's going down as we look left to right. So the m value be less than 0. Just an example like that. We could talk about how something has positive slope. That's where it's going up as we look left to right. And that's where the m value is greater than 0. We talked about slopes of 0 being horizontal. That flat line. And then the undefined slope we mentioned. And that undefined slope, is vertical because m is undefined because we can't divide by 0. Okay, so in that case we have that vertical line. And so, it's different ways to remember it. Negative going down, left to right, 0 going flat. And here's where I made a mistake and I have to go back and reteach you, but hopefully this works. But this no slope, we can refer to no slope as undefined. Okay, so if it's undefined, it has no slope. It doesn't have one. Okay, I didn't explain that very well first. But a 0 slope has a slope. It's just a slope of nothing. Okay, so it has a value of 0. 0 is a number, so we give it a value, and we can differentiate that from not having a slope with this undefined slope. Okay, so let's remember those key parts. When we find slope, okay, just sing that song in your head. It's the difference of the y and the difference of the x. Divide the two and then reduce. Then you got slope. So the rise and the run. And we find the 4 major categories of slope: a negative slope, a positive, a 0, and undefined or no slope.